Hello, welcome back to Economics YouTube channel. We shall be continuing our research writing course, and in today's video we'll be talking about analysis in chapter 5. Now, as I used to say, it depends on your supervisor, it depends on your department, it depends on your school style and stuff like that. Analysis may not be in your own chapter 5, it may be in your own chapter 4. Okay, so it is what it is. Last week, I think it was last week, I was engaged with a project writing, so I had to write the literature review of a particular dissertation, and that was in chapter 2. So if you were to follow what we've been doing in this particular course, or on this particular course, you'd realize that literature review falls in chapter 3. But then that was just how it was, literature review was in chapter 2, and in fact it was more or less a combination of literature review and background to the study. Okay, so like I used to say, depends. But whatever it is you're learning on this course is going to have a general applicability to whatever it is that your school will ask you to do. And before I proceed, I also remember that in that particular literature review, I had to include research gap. Okay, or is it research? No, gap in literature. Yeah, I had to include that gap in literature. I don't think I spoke about that when we're covering chapter 3 of our literature review and what have you. So gap literature is like after you've gone through a lot of journals, literature review. So after you've reviewed a lot of journals, I think at the end of the day, I went through or I reviewed more than 60 journals. Okay, for that particular work. You understand? So after reviewing, after going through, you would have written your methodological review, you'd have written your empirical review, your theoretical review, your conceptual review. So after doing all of those things, you would have realized from your readings that there were some things that were not spoken about. So that formed, my gap in literature that I included in that particular, work. And the supervisor found it nice. Yeah. Anyway, let's come back to what we are doing today. Why I told that story was why I mentioned that. Sorry, is because if I could do literature review in chapter 2, so that means methodology comes in chapter 3 and analysis would have to come in chapter 4. In fact, analysis and discussion of findings may be in chapter 4. So for that particular dissertation, it might end in chapter 4. You understand? So that's about that. Anyway, analysis. So in this particular chapter, I am already assuming that you have your data set. Okay. For me, we've been talking about impact of inflation on Nigeria's economic growth, and if you recall from the previous class, I think in my model I had, I think I started with endogenous growth theory, right? So I had innovation, then I had human capital, I think inflation itself, then government expenditure on health, government expenditure on education. So after going through data, sources and what have you, okay, I came up with some proxy variables which may not have been the same thing with the one I said before we got to this before we are in this particular chapter. So for example, for innovation, I think I wasn't sure whether I should use a number of patents, or I should use research and develop R&D expenditure. But then I got to think of it that wait, sometimes you spend money and you don't get results. So using research and development expenditures as a measure of innovation may not really be it. But why not just use number of patents? You understand? Because at least you've done something. Something is having a patent, right? So that means there is something new, there's something novel. So whether a technology, something that makes production process better, and stuff like that. So I decided that okay, let me use number of patents, and that also depends on the availability of data. Then I remembered that I didn't choose a scope for my study. Okay, and I think I would like to choose, let's say, 19. I wrote something down, but I think I've forgotten. Let me say 1970 to 2021. This is 2022, so obviously I'm not going to have data set for 2022 yet, like the year has not ended. So, and since the data I'm using is an annual data, so it's gonna stop at 2021. So 1970, let me say I'm choosing 1970 to 2021, and one of my reasons is availability of data. And I'm not even sure about that right now, but let's assume that there is no data between 1960 and 1969. So can just say I'm using that and I want my work to be broad enough. Okay, so that's why I'm just using where data began, okay, to the current period. So let's assume that Nigeria's data and most of my variables start from 1970. Okay, so let me just have 1970. So I've provided a justification for my scope of study like that. First, I want the work to be very broad, and two, the data set or some of my data began from 1970. Okay, so I can't go back to 1960 or 1950 or whatever it is. Okay, so that's that about that. Now that's for innovation. Then my proxy variable for human capital, I think I'm using life expectancy. I think, yeah, life expectancy data. I wrote them down. I think I've picked the wrong papers. Okay, so yeah, and okay, let me start. GDP. For GDP, I'm using real GDP data, so like not just GDP again. So in my model, I'll be having real GDP. Okay, which means that I must have adjusted it in my methodology. Okay, remember previous chapter 4. So it's not just GDP in my chapter 4, so it's real GDP. So I'm having real GDP. Okay, equals to inflation. Okay, alpha naught plus alpha 1 innovation plus alpha 2 human capital plus alpha 3 inflation plus alpha 4 government expenditure on health plus alpha 5 government expenditure on education plus my error term, okay, ET or UT or whatever it is you want to denote it with. Okay, so for my human capital, I'm using life expectancy. Okay, yeah, that's what's on in this file. Then for inflation, I'm using inflation rates, CPI. Yeah. Okay, when you check WDI, World Development Indicator, so there's a measure. There are two measures for inflation rate. So there's one inflation rate that is derived from GDP deflator. So you see inflation rate, GDP deflator. But the one I want to use is inflation, CPI. Okay, looking at inflation from the consumer perspective, not the producer perspective. Okay, so by now, as an economics student, you should know why. When CPI is used to calculate inflation, whatever it is that you're trying to drive at, you should know that difference. From when you're using a GDP deflator. I shouldn't be teaching you that. Newly. Okay, so after that, then I have government expenditure on education. So for that, okay, I got proxy variable. The data set that I'm going to be using is government expenditure on education. So there's a data set like that in World Development Indicators. Then government expenditure on health. So the data set I will be using is domestic general government health expenditure per capita. Okay, domestic general government health expenditure per capita. You see, so that means the data I have, the one that is available for me to use to proxy government expenditure on health, is actually the one available per person per capita. You understand? And it's okay. It's okay. Now there might be other proxy variables that I may have used, if I had known about them, or if I had found them, better than this one than this that I want to use. Okay, so well, whatever. So that's that about that. So whenever you have to select your data there's a way to check proxy variables. So just go online. Let's say you have WDI, World Development Indicators data, like myself. Okay, and you just want to check, is there government expenditure on health in WDI? So more or less just type into the search box on Google or whatever search engine you are using, government expenditure on health or government health expenditure proxy in WDI. You understand? PROXY. So it will give you the variable that captures government expenditure on health, or it will give you the list of variables in WDI that capture government expenditure on health. So I really want you guys to know how to do analysis, like know how to go about your projects, even though you may eventually not do your analysis by yourself. Someone like me, he may contact me or contract the stuff to me, and I'm going to do it for you. Terms and conditions apply, so I can even write a project for you, some part of your project. There's no problem with that. But whatever it is, you will likely have to defend your project at the end of the day, so you should be able to understand each and every aspect of your project. Okay, so you should be able to understand your analysis, you should be able to understand your methodology, so by the time you want to defend it, it's not going to be a big problem. So I think that's all about my selection of data set. So your chapter 5 contains some important things. So your descriptive statistics, that is what every or the journals or papers I've seen, whenever they want to talk about the analysis, that is where they start from, descriptive analysis. So you have to describe the data set you are using. Okay, you have to describe the variables, and when you are describing, what you are looking for is the mean, minimum value, maximum value, standard deviation. Now this might also vary depending on the school, but for me, okay, so whenever I'm writing descriptive statistics, except the supervisor says otherwise, so these are just the 4 things I'm going to include. I'll create a table. Okay, then I have the variable, the minimum value. No, I'm not the one that would calculate that or start looking at. So that is where statistical package is coming. Okay, so in this particular video, it is expected that you have a statistical package that you want to use, and if you don't, okay, there are softwares that you can use. So you have eViews. I am used to eViews. All right, so I'm going to be using eViews at least for now. Okay, then you have SPSS. That is usually great for primary data. Then we have Stata, okay, or Stata, whatever it is that is called, STATA. That's another statistical package. Then you have R, you have Python, you have whatever. So, and I don't know what year you might be seeing this video, so you might you might come across, you something else. Okay, that is, just make sure it is efficient. All right, so you need a statistical package. So for me, I'll be using eViews, and at this particular period, one of my computers is eViews 9. Okay, so what I'm going to do is, I won't be teaching you how to use eViews. Okay, so I'm just gonna try to leave the links of how to do these things, okay, in the description of this particular video. So if I don't leave it there, please remind me, okay, by the time you are going through this particular class. So for example, a link to how to do descriptive statistics on eViews. Okay, and you could just go on YouTube on your own. So how, in the search box, how to do descriptive statistics in eViews. Okay, so you see it's easy. So when you do it, you're gonna have several items. You have mean, you have median, you have minimum value, maximum value, you have standard deviation, you have curtois, is it curtois or whatever, KURTOIS. You have the Jacobian statistics, statistic. Okay, then some other things. I think it also depends on the statistical package that you are using. So out of all of those things, for me, I'll just choose 4 things I want to talk about: mean, median, mean, minimum, maximum, and standard deviation. Okay, so you'll be carrying out descriptive statistics for every of your variable. So for me, looking at my model, I've not written it. I've written it so many times. Okay, before this particular class, I will be having, I think, 5 variables. Real GDP 1, innovation 2, human capital 3, inflation 4. Government expenditure on health and education, those 5 and 6. So I'll be having 6 variables. So here, under variable, I'll have 6 variables. So I've written real GDP, innovation, inflation, from CPI, expressed in percentage, then whatever comes under it. So real GDP, you must be able to write the unit of measurement. So real GDP in brackets, millions of US dollars. Okay, whatever unit of measurement that you are using. Innovation, because I'm using number of patents. Okay, so I may just leave it like that, like innovation, just leave it like that. So 3,000, maybe the main value was 3,000, minimum is 1,000, whatever. Then if I see that, okay, my number of patents happens to be in millions, so I can just put innovation in brackets, millions. That's all. So that's to tell you that whenever you're reading whatever value I put inside in front of innovation, so those values happen to be in millions. Okay, the same thing for inflation is going to be in percentage, so that's why percentage is there. So if you see 115 here, it means 115%. So that's how you're going to do your descriptive statistics, the table. So after that, what you have to do is the story. You have to talk about what is on your table. So you don't just leave it like that. So descriptive statistics is just all about, okay, Nigeria's real GDP over the study period, which is already talking about 1970 to 2021. Okay, over the study, Nigeria's GDP had an average value of $609 billion over the study period. So when I'm talking about average value, so that means mean. So $609 billion. So that means 609 is going to be here, and here my unit of measurement will be billions, in bracket billions of dollars. Okay, there's a sign for dollars, that S sign, then billions in front. So 609. Okay, the country had its lowest real GDP value, okay, which is given as let's say 112 minimum, $112 billion, and its highest real GDP value, let's say it was $1025 billion. Now you can't talk about the year, you don't know the year, okay, because the table doesn't show the year. So just what's the mean? The standard deviation, you may not even talk about it, although it's gonna have a value, but you may not even talk about it. So the value may be, let's say 3026.115 or whatever. Now it also doesn't mean that these values will be whole number. So for me, I try to leave my values in 4 decimal places. Okay, so let's say 609 were 609.1. So I'll just write 609.1000 4 decimal place. So I just make sure that all of my values are uniform. So I leave each and every one of them in 4 decimal places. So that's how you'll be talking about, each and every one of the variables here, their mean, their median, and what their mean, their minimum value, maximum value. So I don't talk about standard deviation. It's not like I don't really talk about it, but I just put it there. Now your supervisor may ask you to put other things and ask you to talk about them as well. So like reports what is on the table, or what is in the table. And one thing I want to mention is sometimes you have to compare. Okay, so if there are things that you can compare, please do that, because you are describing, okay, you are putting words. Numbers really don't make much of sense except you give them meaning, you attribute meanings to them. So now, for example, there's one analysis I'm working on right now, a project analysis I'm working on. I started this morning. I started before, but officially I started this morning. And under my descriptive statistics, I tend to have two: Nigeria's real GDP per capita and United States real GDP per capita. Okay, because the work is about Nigeria's international trade, import, export, whatever. So in the model, Nigeria's real GDP per capita is in the import model, and United States real GDP per capita is in the export model. I think, if I'm not mixing stuff, right? Okay, not as if they are in the same models. I have 3 models for that particular research, and I'm still working on it. So because I have those two, because I have things that I could compare, so I was like, in comparison, the United States has done better in terms of real GDP per capita than Nigeria, and this can be shown from the average values of the respective countries' GDP per capita. Okay, Nigeria's average real GDP per capita over the study period is I don't even remember what it is right now, but let me say $2,509, and that's per annum per year, while America's own is $44,503.5671 dollars per annum. Okay, now the situation is worsened when we compare the minimum and maximum real GDP per capita of Nigeria with respect to the United States. Okay, the least, which is, I'm already talking about the minimum now. Okay, the least value of the United States real GDP per capita is greater than Nigeria's maximum highest value of its own real GDP per capita. So I'm already comparing United States mean and Nigeria's max. Okay, then we can also realize, okay, that the least, or let me say, the lowest real GDP per capita value of the United States of American citizens is 10 times better than Nigeria's highest real GDP per, so stuff like that. Just create a story around it. Okay, so something like that. That was kind of what I did this morning, and it was nice to me. So just give it a story. That's that about that. Now, when you are done with your descriptive statistics, then move to your unit rule. So your unit rule test is talking about test for stationarity. Are your variables stationary? So here you could also go online. Okay, go on YouTube and go and download videos on how to carry out unit rule test on e-views. Okay, so there, but here there is a decision rule. So you have your null hypothesis, which is assuming that your variable is non-stationary. Okay, and then you have your alternative hypothesis, which is H1, that is assuming that your variables are stationary. Now you can reject the null hypothesis or fail to reject it. So in econometric jargon, you don't accept null hypothesis, you fail to reject it. Okay, so now by the time you carry out your unit root test, you will eventually have to come up with a table for it as well to to put it in this form, in a form that makes sense. And by the time you carry out your unit root test, all right, so by the time you carry out your unit root test, it's not going to display this way. It displays in a way that you're going to be having your augmented Dickey-Fuller statistic, so that's ADF statistic. So you see it, you see the value in front. Then you're going to be having critical values. Your critical values for 1%, for 1% level of significance, a 5% level of significance, and 10% level of significance. Then you're going to be having a p-value, probability value. Okay, so the one that you're really concerned with is the critical value at 5%. So you just pick the value in front of the one on 5%. Okay, and that's what is what really concerns you there. Then you also write the ADF statistic. You're going to see it in front. It's not a big deal. You're going to see it in front of it. Okay, when you are using EViews, if you use EViews carry out your unit root test, whatever package you use, you should be able to see that. So whatever value you have, you write it. So for example now, okay, here, because in my model, what I'm going to be doing is I'll be using the log form of my variables. Okay, so I'm carrying out unit root test for the log form of the variables. Okay, now you see, okay, one thing I should also explain is that you see under descriptive statistics, some researchers will log these variables and then find descriptive statistics of the logged version of the variables. So to me, it doesn't really make sense. For example, if this were log real GDP now, L real GDP, of course this is not going to be 60 now. I've told you one reason why people log, to reduce to shrink the size of a data set if it happens to be very large. Now here maybe they're expressed in billions of dollars, but you want to shrink them, you don't want them to be that large. So I have log real GDP, then here I have 30.4526. So how am I going to explain that? Nigeria's average real GDP is 30.56. That's not it. You understand? So that's why I just decided to use the normal version of the variables, the one I've not logged. Okay, but here when I'm carrying out unit root test, because my model at the end of the day is going to be lane real GDP equals alpha 1 plus lane innovation plus lane human capital plus lane, because I'm logging all of them. So I should carry out the unit root test for the logged form of the variables. You may not be logging your own variables, so even if you won't be logging your variables for your particular research, okay, so just use the normal form. Okay, so it's important that I tell you that. So when you carry out your unit root test, so you have your ADF, as I've mentioned, you have your critical value. Then when you are carrying it out, of course you get to a point where you are going to be asked, are you doing this test, are you conducting the unit root test at levels, at first difference or at second difference? So now what you really need for the ARDL model that I'm going to be using, or that I'm assumed to be using in this chapter, I already spoke about my methodology that I want to use ARDL. So I want my variables to be stationary at first difference maximum. So if they are not stationary at first difference, then that means I can't use ARDL again. So they might be stationary at the levels, which is I naught, okay, I naught that I have here, and they might be stationary at first difference, which is I1. Okay, so lag I naught is talking about levels, okay, lag I1 is talking about first difference. These are the kind of things that I think teachers, economic teachers ought to be teaching students in school, but no, I think I was learning how to calculate AMA 1 and stuff like that. Some things that let me talk. Okay, so after that, then you have a p-value. So I was talking about decision rule. So if your p-value, your probability value, if it is greater than 5%, that is, if it is greater than 0.05, okay, this is greater than 0.05, that means your critical value is not statistically significant, and then you fail to reject your null hypothesis that assumes that your variable is non-stationary. Okay, repeat, I'm saying it again. The decision rule is, you looking at it, is your p-value more equal to more or less than 0.05. okay, if your p-value were less than 0.05, that means that your variable is stationary. That means it is statistically significant because it is less than 0.05. okay, but if it were equal to 0.05, that's 5%, that means your variable is statistically, your critical value is statistically significant at 5%, which means, okay, that your variable is um, stationary, okay, at whatever it is. So for example, in this place, I did it in real GDP. I got a particular ADF statistic, then I got a critical value. I got 1.3542. Then because I was carrying out my unit root test at levels, okay, by the time I start watching how to carry out unit root tests on e-views, if you haven't done that before, you understand what I'm saying. You just get the theory, and when you're in the practical, you apply whatever it is you've learned. So at levels, which is like I naught, so I represent as 0. So levels means, so under like I naught, you put zeros all through, since what you are carrying out is under level. Okay, there's a level here, and I start with first difference. Now this is a table, a proper table, so you are going to like have to draw insert a proper table in your Word documents, and explain this very well. And you can place levels and first difference side by side. Here I don't have enough space, so I place levels above and first difference, so assuming that they're like two tables, or they might even be inside the same table, but levels, all my unit root test results under levels, they are above, and first difference they are underneath. Okay, so I have series, lean, real GDP, ADS statistics gave me something, and I checked my critical value at 5%. I got 1.3542. Okay, then because I was doing that levels, of course, like I know this is going to be 0 here. Then p-value, I said my p-value was 0.1264. Now if you look at the 0.12 is greater than 0.05. okay, so that means my critical value here is not statistically significant. Is not statistically significant, which means that I will fail. Okay, it is greater. Look at it, it is greater here, which means that I will fail to reject the null hypothesis that says that this variable is non-stationary. Okay, it's more or less saying that I will accept the null hypothesis. Do you understand? But you don't say accept null hypothesis, so you fail to reject. I told you that it's an econometric jargon. Okay, so I fail to reject the null hypothesis that says that my variable is non-stationary, so which means my variable has unit roots. That's the meaning. At levels it has unit root. Okay, now let's talk about lean inflation. Then I have ADF statistic, I write it. They might be the same, no big, they might be the same. And critical value, they shouldn't be the same. All right, they shouldn't. They might be, but they shouldn't. Okay, so they might be anything. Don't let me say they shouldn't. It might be anything. So I have 4.1618. Of course, it's this level, so 0, like 0. Okay, then my p-value gave me 0.0225. So if you look at 0.02 is lesser than 0.05, which means this is statistically significant. Okay, and because it is statistically significant, so that means we will reject the null hypothesis that says that this variable is non-stationary. We will reject the null hypothesis that says this variable is non-stationary. Therefore, the variable is stationary. You understand? Or therefore, we will reject that this variable is null hypothesis that says this variable is non-stationary. Therefore, we fail to reject the alternative hypothesis that says this variable is stationary at 5%. It's something like that. It may not exactly be in the way I've constructed my words. Okay, so that's just it. So which means lean inflation does not have unit roots. Okay, it is stationary at levels. If it's stationary at levels, it's going to be stationary at first difference. Do you understand? So I have, then you do for other variables, the remaining variables, complete that. Then you come to first difference. Okay, so under first difference, the same thing, series. Under series, you write all of your variables, ADF statistic, critical value. So here, I decided to write the ADF statistic, 2.56, 2.5, they might be the same, 2.5 is 2.5. Then critical value of linear GDP at first difference now, so which is lag 1. So I have 0.1153. Lag 1 is 1, so 1 is going to be under that lag all through for all the variables. Then my p-value 0.0002. Of course, this is what lesser than 0.05, which means that it's the value is statistically was significant because the p-value is lesser than 5%, and as a result, we reject the null hypothesis that says that this variable is non-stationary. Okay, which otherwise is at 5%, which otherwise is saying that we accept the alternative. We fail to reject the alternative hypothesis that says that this variable is stationary. You understand? So therefore, um, lean real GDP is stationary at first difference. Now because it is stationary, so I could just put here it was not stationary, I could just put NS. Then here stationary S. So here stationary, I can just put S. But underneath, I'm gonna write where NS represents non-stationary and S represents stationary. You understand? So that's gonna be like a guide for whoever is reading it to understand the meaning of NS and S. Don't just assume that the person knows. Then I skip something. Under this table, you're gonna write source. Okay, for me, source, a colon. Okay, author's computation using if use. I was one that wrote designed the table kind of this way. So author's computation using if use, because I got my data, I got the result from if use. So author's computation using if use. Okay, some might put the version if use 10, if use 9, if use 12, if use whatever. Okay, now here under your unit roots table as well, so author's computation using if use. All right, so then lean inflation, I got my idea statistic, I got my critical value like I1, so 0.018. So this is also lesser than what 0.05, which means that the value is statistically significant, and it's already telling you that you reject another hypothesis that says that the variable has unit root, or the variable is non-stationary at